the trends and the challenges when it comes to ozonation. What are very big trends in the water industry? Well, we have split them up in these three very big areas. We know there is also process water, like industrial water, but let's limit it to those three. So let's start with drinking water production. Well, there are new sources being used. We know multiple utilities right now that used to be 100% groundwater companies, and now they are looking into starting to use surface water as a drinking water source. A very big shift, because everybody knows these treatment trains are very, very different. The dynamics are very different. There are also new target chemicals to be removed, and also many of the plants have capacity changes, increase, decrease, or are facing retrofits. So these are quite some challenges there. When you look at indirect or direct potable reuse, ozone plus maybe activated carbon adsorption is becoming a new gold standard. This means in the past it was all membranes, RO, very tough, let's say, or very strict multiple barrier concepts. While ozone is really emerging. Look at SWIFT, for example. SWIFT is a project in Virginia by HRSD, one of the biggest reuse projects in the world that is ozone-based. And these are some pictures of the current research facility. One big example, but look at California, a state in the US that is very hard on water use. They're also looking into ozone. Big shift there. And then at the wastewater side, the biggest topic over there is micropollutant removal. Look what happens right now with the revision of the Urban Wastewater Treatment Directive. It is literally for the first time ever stating that plants above a certain level will need to remove micropollutants. So this is really a work of, let's say, 2 decades to get it into the regulation. Big shift. So this is the first poll, and you will normally see it on the screen right now. So what application domain of ozone or multiple of them are you most active in? What is most relevant to you? So votes are coming in. I already see we have a nice mix of people here. Okay. So let's give it 5 more seconds. Yeah, for your votes. Okay, let's bring up the vote. I will now share the results. So normally you should be able to see the results right now. It's nicely mixed, right? So we have many people working on drinking water, 1/3 or something more on wastewater, and then also water reuse. So thanks for the votes, a very interesting mixture of people. Okay, so let's continue. What are the challenges when it comes to implementing or operating an ozonation process? Well, there are 4 big ones, more of them, but 4 big ones that come to our mind immediately. They were tackled in our previous webinars in detail, so you can definitely look at the recordings. The first one is every water matrix is unique. This means every design, every operational strategy for each site will also be unique. It's a mixture of chemicals, and how ozone behaves or performs in a certain water matrix at a certain plant is really driven by the matrix. Second challenge is lab or pilot testing takes quite long. It can really take up to multiple years. It is quite expensive, but the problem is a bit that it leaves many questions still unanswered when it comes to design. So that's a second challenge we have defined in the industry. A third one is design is a balancing act because you have costs, operational costs or investments, but then you have the performance. Okay, what is my disinfection, my CT, or what is the removal of my micropollutants? But then you also have your byproducts. Specifically, we are targeting bromate here. So you really have to balance all of those things together. And finally, in the end, the key variables that are hard, the key variables that you are really interested in are hard and expensive to measure. For example, up until today, there is not a good sensor for bromates online. There is also no sensor that will tell you in real time what is your removal performance of your micropollutants, for example. So these are quite some challenges. So this is why we have been building AMOZONE, which is a process model that contains a lot of chemistry. You can see that here. This is very complex. We will not go into very detail, but all these equations are in there. So it's a mechanistic model, not a data-driven model. But the front end looks a bit more simple. It is a virtual plant that is displayed here, and it gives you some outputs as function of time or averages. Yeah, for example, in this case, bromine. We were glad to win the Water Europe Innovation Award 2021 with this model, because Europe stressed the importance for also in the framework of new regulation. Now, we started applying it commercially 5 years ago. Where is it now being applied? That's the big question. Well, the first one is in the planning or exploration phase. So we do look at technology selection and feasibility. In this stage, we call this virtual piloting. So we are in this stage completely or partially replacing on-site piloting by computer simulation. And in this case, the questions you have is performance, feasibility, the costs of such a potential future plant. Yeah. Then once the decision is taken and people go into the design stage, we help applying the model in conceptual and this detailed design to really have a well-functioning process, because fixing a reactor design once it's built is very difficult. So here the key questions are, what is the dimensions needed? What is the design? And detailed design can literally mean, where do I put my diffusers? Should we move a baffle wall? It can be really detailed. And then once it's built and it goes into operation, new questions arise, and we use the same model for smart operation and training. Training is very important as well. We have seen that, especially if you're new to ozone, but this is called the digital twin application. So a model that predicts what you cannot measure based on what you can measure for real-time monitoring or what-if testing. So here is the next question on a poll. So which stage describes most your situation when it comes to ozonation? So either you're exploring or planning, you are in design stage, you are building a plant right now, or you're already operating one or multiple ozonation plants. Okay, let's give it 5 more seconds. And here are the results of the poll. All right, I will be sharing them now. So most of you, almost half, are in exploration planning stage. Very good moment to follow this webinar, I would say. So in that stage, you really want to learn a lot at a fast pace, what is being done at other sites. People are also in design stage, 20%, and some people are constructing, and a nice percentage is also operating already. So there is quite some experience in this audience already. So this is very promising for the Q&A. Good. Now we come to the most interesting part, the case studies. Let's introduce them a little bit. We have selected a few because we can, we have to limit a little bit that it's a good mixture. We have decided to make a mixture between virtual piloting, design, and also digital twins. So we have one plant from Sweden that we helped developing together with Sweco. So we did a virtual piloting for that plant, wastewater. So these are these brown droplets. If you see them appearing in the webinar, these are wastewater related cases. The blue ones are drinking water related, okay? Then we have another one in the Netherlands where we first did the virtual piloting in 2021. We helped the design in 2022 and currently /23, and currently we are building the digital twin. Yeah, so this is a plant going through all of the stages. We have a plant from the Netherlands, another one, a drinking water treatment plant, where we are mainly focusing on the digital twin. And then we have a French case where we will be focusing on design and also a digital twin, and another French case on design or a redesign. So this is